Hello everyone, welcome back to our channel. Today, let's dive into the world of smart gardening. So, this little device is a game changer for plant enthusiasts and professional gardeners. This helps you in monitoring the soil moisture level in real time. To make this project, what are all the components required? So, since this is an IoT based project, we need a microcontroller which is having Wi-Fi accessibility. So, we are using Raspberry Pi Pico W, which is having inbuilt Wi-Fi and Bluetooth. You can even use ESP32 as well. To measure the soil moisture level, we are using soil moisture sensor, which is affordable at the same time easy to use. And to power the whole system, we are using lithium-ion batteries. 2 lithium-ion batteries we are using. So overall, we'll get 7.4 volt. But for a microcontroller, we need a stable 5 volt. So what we are doing, we are using a 7805 voltage regulator module. So what does this? It will convert that 7.4 into 5 volt regulated voltage. And we are using one diode to give it a reverse polarity protection. And a toggle switch to on and off the whole system. Since this is a rechargeable lithium-ion batteries, we need a charger circuit. So we are using TP5100 charger module, which will charge the lithium-ion batteries. So let's analyze the circuit diagram of this project. It's a very basic circuit diagram. Here we have Raspberry Pi Pico W and 3 soil moisture sensor and 7805 voltage regulator and diode, 2 lithium-ion batteries and TP5100 charger module, lithium-ion battery charger module. So let's go as a flow. First we have 12 volt here. So this is used to charge the lithium-ion batteries. So TP5100 is a charger module, so it will convert the 12 volt and make it possible for a lithium-ion battery to get charged. And after that, we have a switch. So through this switch, we will turn on and off the whole circuit. So we'll get power to 7805. So this lithium-ion battery gives 7.4 volt. So it will convert that to 5 volt. So using 7805 voltage regulator module. And for reverse polarity protection, we are using diode, so nothing harm will happen to Pico. And Pico is very voltage sensitive microcontroller, so you have to give proper 5 volt, otherwise it will burn. Unlike other microcontroller like Arduino and ESP, you can give 7 volt directly to V in pin. But here you can't do it, you have to give proper 5 volt. For that we are having this circuit, and we have to give that to VSYS pin of Pico. And common ground will be connected here. And there is a 3.3 output pin, so that is connected to soil moisture pins 3.3 and another G and D pin. So through this we will power the soil moisture sensor soil moisture sensor. So we have three conducting part of soil moisture sensor through which we will find out the moisture. And we have 3 ADC pin, analog to digital converter. So Pico is having only 3 analog to digital converter. So we can use maximum 3 sensors. So which is pin number 28, 27 and 26. We can connect to only these 3. So through these 3 pin we are getting analog data. So let's start with the demonstration. Here I have taken one plant and 2 glass of water which will give a moisture value. Then to see the values, the laptop is ready and the server is running now, and let's power the system and we'll put the soil moisture sensor inside this one. And other 2 will be inside the water like this. And in the laptop you can see all the data are coming, all 3 sensor data with timestamp. So what time, what date we are getting data, and the average of all these 3. So I will remove one sensor. So as you can see, the sensor 1 value is getting down. Now I will remove another sensor, and another sensor value is also getting less. So now what I am going to do, I will put 2 glass of water into the pot and we will see if the value is increasing or not. So the third sensor value is increasing. As I poured water, the values are increasing. So as I remove the soil moisture sensor, I am getting an email notification. So what is that notification is telling? Sensor 1 need watering. So I removed sensor 1 and I am getting another email which is telling sensor 2 need water. So we will get email message, so when to put water to which particular sensor. So like this project is helping us in maintaining soil moisture level in the plant.
So to coming to the coding point of view, here we have used Pico. So in Pico we use MicroPython. For MicroPython we use Thorny. So this is a Thorny application, and here I have selected Raspberry Pi Pico. So timing now I have not connected, I am just displaying you the code. So here these are the 5 libraries which I am using: import machine, asynchro, network, JSON and utime. To giving this Wi-Fi, I am giving it my username and password of my Wi-Fi. Then I am testing it to connect to the network. It is connecting here, we can see by this code, by this line of code, and if it is not connected, so after every second it will display connecting to network. And after this, coming to the pin configuration. So in Pico we are having 3 analog pin, 26, 27, 28. So we have connected all these 3 pin to all these 3 sensor pins to 26, 27, 28. Along with it, we have introduced buzzer. Buzzer we have connected to pin number of 11. So after this, we are reading the value. We are reading the value, so we will get their analog value, but we want it in percent. So its value will range from 0 to 65535. So we are dividing that value by 65535 and multiplying by 100, so that we will get its analog value. And after that, if its value will be less than 40, then we want the buzzer to on, so that a user can get notified. So for that we are using this. If any value will less than 40, in case of percentage, then buzzer will get on. In other case, it will get as off. After this, to display all this data, we have created a small HTML page. So for that, we have written here HTML code. This is a very basic HTML code, and in this is the CSS part where I mentioned about body, h1, table, and we have created table to get to know all the sensors value. So we are getting the sensor value the timestamp, sensor 1, sensor 2, sensor 3, and we are getting also average. So we are, as I told earlier also, we have imported JSON. So with the help of that JSON library, we are converting all this data, and we are getting. So we are taking the values after decimal till 2 point. So data dot 1, sensor dot 2 fixed 2, and we are taking here timestamp. Along with it, we have put here delay of 1 second for the web server. So after this, now we are sent, like this HTML code is written. HTML is receiving the data, but we have to send the data. For sending this data, we are using async. In this, we are using a reader and writer function. If it is a true, then it will read from the line and it will send all the response data. As we have designed, declared the pin 012, 26, 27, 28 sensor pin, and we are defining with sensor 1, sensor 2, sensor 3 data, and we are then after that we are taking average. What is average? Average value, which is sum of all the sensor and divided by number of sensors, which is 3 here in this case. After this, we are dumping the data, we are writing on the web server, and if it is not connected, then it will show connection error. So this is the very basic code. We are using the port of 18, and while coming to the this HTML page, so I can demonstrate you with this one data. So when I will connect this to Wi-Fi, I will get its IP address, and when I will run this program, I will get its IP address, and when I will go with that IP address, then I will get all the sensor data. Here I am getting all the timestamp, sensor 1 value, sensor 2 value, sensor 3 value, and here I am getting its average value. So here all the data will get stored. So when we are putting into water, it is getting more and more moisture. At that time, we can see this value are increasing.